So now we're just going to determine the horizontal asymptotes of this big equation. So I know at this point that my horizontal asymptotes happen as x approaches positive infinity and as x approaches negative infinity. So let's just build that into one equation for now. Of 7 minus x over 5x plus root 16x squared. So this is my equation. I know that it's always going to come from my highest power of my variable. So right now my highest power of my variable is a 1 here and also a 1 in the denominator. It's a 1 in the denominator because I know that the square root of x squared has a power of 1. So let's look into solving it. So I'm going to start taking something out of the radical in the denominator. So I know that the square root of x squared is equal to x. So let's start out by taking out an x squared. So I'm going to do the limit as x approaches positive and negative infinity. My top is staying the same. Right now I'm only worrying about my bottom. So since I'm taking out an x squared, I'm going to put an x squared in brackets and then see what's left behind. So left behind I have a 16, a minus 3. Since I took out an x squared, this x here would be x over x squared, which means I have a 1 over x there. Then I have a plus 4. There was no x there, so that's going to be divided by x squared. So just for some notes, this is the exact same thing as this. So I know some people write it different ways. So continuing to move on, when I take out that x squared, I have to do an absolute value to it because I know the square root of something could be positive or negative of that number. So I'm going to do plus the absolute value of x because that is coming out as an x. So now I have to break it up into two different ways. I'm going to break it up into x approaching positive infinity and x approaching negative infinity. So let's do the limit as x approaches positive infinity first. So I know when x is approaching positive infinity, my x values are positive. So on the denominator, my absolute value of x will be replaced by positive x. And then I just have all of this stuff. Sorry, these were supposed to be root signs. So now I have everything simplified as far as I can, and I divide by my highest power of x. So I'm dividing everything by x because my highest power is 1. So that's going to give me a limit as x approaches positive infinity of 7 over x minus x over x, which is just 1, all over 5x over x plus x over x. And then what's in your radical is going to stay the same since that's multiplying on to this x divided by x. So I don't need to divide that stuff again. So then my solution, this would go away because 7 over infinity is just 0. So I have negative x divided by x is 1. So I have a negative 1 on the top. On the bottom I have 5x divided by x, so just a 5, plus 1 root 16. This is 0. This is 0. So I can just simplify this once again. So I have negative 1 over 5 plus root 16. Root 16 is 4. So negative 1 over 9. Then I have to do my limit as x approaches positive infinity. Or sorry, negative infinity. So this time, I know that my absolute value of x needs to be negative x because as I'm approaching negative infinity, all of my x values will be negative. So I have 5x minus x now, square root of 16 minus 3 over x plus 4 over x squared. So dividing all those terms by x again, because my highest power is still x to the power of 1. So on my top, I'm still going to get the same thing here, but my denominator is now different. So I still have 5x divided by x, but now I have subtract x over x, root 16 minus 3 over x, plus 4 over x squared. So filling my values in now, 7 over x is 0, and then x over x is negative 1. Perfect. Then I still have 5, because my x's will cancel here. Subtract 1, x's cancel, root 16. So perfect. My answer now is going to be negative 1 over 5 minus 4, which is negative 1. Perfect. So now I know that I have a horizontal asymptote at y equals negative 1 over 9 from my limit as it approaches positive infinity. And I have one as y is equal to negative 1 when your x value is approaching negative infinity.